Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecule. Today's question is in front of you. So what is the major product of this reaction? I request you student, please read the problem carefully, pause the video, try by yourself, and whatever answer you get, please write in the comment box, and along with the answer, please write few words about the explanation. Let me give you a hint. This is a very easy problem, but it's a little tricky problem. So if you understand this, I guess very soon you can solve it. But don't worry, after some time you will get the right answer. I believe you have tried by yourself, so it's my turn to give you the answer. Just look at this molecule. And what are reagents? First ozone, then dimethyl sulfide, third H+. If you look at the reaction number 1 and 2 condition, this is nothing but a condition for ozonolysis. Okay, and ozonolysis, here alkene is given, or more specifically if I say it's an activated alkene. Why? Because there is a oxygen atom attached directly to this pi bond, this carbon oxygen, this carbon, and this is actually an alkene, so it can open up and ultimately it can produce, this is the negative, this is the OSI Me3. Okay, so from here you can understand this is activated. I am not showing other thing. So this is an electron rich activated system. It will react. Now let's discuss about the mechanism. So first, ozone reacts with this alkene and ultimately it produces an addition product. Okay, and by the way, I have already discussed many lectures on ozonolysis, so you may visit for better understanding. So this product will be produced later on. We know that this will further rearrange, means one oxygen will come here, then I'm not going that thing. So ultimately it will produce, you may visit that video for better understanding. It will react further and it will produce this dicarbonyl. Now this is the dicarbonyl derivative, and remember student, what is the role of this dimethyl sulfide? This dimethyl sulfide is actually a reducing agent. Reducing agent means during the ozonolysis, this along with this carbon-carbon double bond, to oxygen get attached, means carbon will produce, and along with that it produces 1 unit of hydrogen peroxide. So this hydrogen peroxide is oxidizing in nature. In order to consume that hydrogen peroxide, this dimethyl sulfide is used, which converted into dimethyl sulfoxide or DMSO. Okay, in this way it prevents the over oxidation of the carbonyl product, or in this case this dicarbonyl derivative. Now what happens in this case? So just from this discussion you can understand that it produces one dicarbonyl compound, and this dicarbonyl compound, if you look at, one is aldehyde, so this is aldehyde, and another, this is actually ester, or you may say silyl ester, or you may say carboxylic acid derivative. Question: why? Generally previously we have seen that ozonolysis created either aldehyde or ketone. Why in this case ester? Because previously there was a oxygen carbon bond formed, so you may consider that this part was previously oxidized, so one side is extra oxidized into corresponding ester derivative. Now so this we understood what is produced, and in the next stage this is H plus given. So H plus, what it will do, it will hydrolysis this ester, or more specifically if I say that it hydrolyzes this oxygen silicon bond, and ultimately it produces one side carboxylic acid and another side is aldehyde. And by the way students, sometime you may feel any difficulty from a ring compound to how we conclude the final open chain. For that purpose it is better to open the ring and write, and for that purpose you need to understand the numbering system. Means this is 1 2 3 4 5 6, so it's a 6 carbon species, so just draw a 6 carbon species. Okay, so in carbon 1 the ester, so this is 1, second 2, this is 3, this is 4, this is 5, this is 6. Now check, just look at the number. R3 top stereochemistry, R3 top stereochemistry, and R5 down stereochemistry, R5 down. Okay, and in this way you will not have any mistakes. So in the next step, this part will be hydrolyzed and it will be converted into corresponding carboxylic acid. So answer is this one. Now in this case student, what are the name reaction or key step associated with this conversion? First step is ozonolysis of this activated alkene, or you can say enol ether, to corresponding this ozone added species. Subsequently, this dimethyl sulfide act as a reducing agent to get the carbonyl aldehyde. Actually, it stops the further oxidation. And third step is workup, which is nothing but an ester hydrolysis. So now what is the answer? So just student, look at that carboxyl group in 3 position, top, closer to carboxylic group, this R is top. Closer to carboxyl group, R is top. One option, closer to carboxyl group, R is top. Yes, with these two. But what was the numbering? 1, 2, 3. See, that's the importance of numbering. So 3, 1, 2, 3. Here 1 and 2. No, gone. So just imagine, based on this is the easy. So answer of today's problem is this one. Now, as I told, it has, if this question appear in your exam, how can you solve? This is a very easy but tricky. What is the trick? Just trick is that along with carbon double bond, put ozone. Means that this is OSI-Me3 as it is. This is one double bond. This. So this is another. Now numbering, just student please do this numbering. 3, 4, 5, 6. It's a 6 member ring. So 1, 2, 3, 4, 5, 6. Now closer to, so this part will be acid, just from this thing you can understand, and closer to this R1 is top side. So if you can understand this, fine. You don't need to write everything, just consider that okay, this bond will break, this part will be aldehyde, so closer to aldehyde, R2 down, closer to aldehyde, R2 down, next carbon, closer to aldehyde, R2 down, closer to aldehyde, next carbon, R2 down, gone. So only one option left. This is a very easy problem, but it's a tricky problem. Okay, so this is the answer. I guess even less than 30 seconds you can solve. Now in conclusion, what you have learned today, enol ethers are alkene and they show reaction like activated alkene plus or effect of oxygen. One side of enol ether are 1 unit extra oxygen oxidized because O carbon oxygen bond is there, and ozone is actually an oxidizing agent, student. By the way, one part resulted carboxylic acid and another part resulted aldehyde or ketone depending on the substituent upon controlled reaction condition, means in presence of a reducing agent, in this case DMSO. In some other example you can see zinc dust, triphenyl phosphine, etc., which also play the same role. And the most important point is that silicon oxygen bond is stronger due to partial double bond character, which is d pi p pi bond. And by the way, I've already uploaded many lectures on enolate and silyl enol ether, so you may visit for better understanding. So these, for further study, you can see this paper, which is the ozonization of siloxyalkenes. So you can learn more. This is the end of the discussion. Thanks for watching, and if you consider my content to be worthy, then please help this channel to grow, and you may visit my another channel where I upload global warming and climate change related videos. So stay happy, stay blessed. See you in my next video. Bye bye.